Welcome back. We are still in section 4.3 and we're taking a look at example B, and we're taking a look at the intersection with a line given parametrics and a plane given its scalar. So with your line, taking a look at your parametrics, I can tell that it has a direction vector of 2, -1, 1, and it's going to have a point of 0, 1, -4. Taking a look at your plane, it's going to have a normal of 1, 4, 2. So we're going to start off our investigation by taking a look at the direction vector dotted with the normal. So 2, -1, 1, dot 1, 4, 2 is going to be 2 minus 4 plus 2, which is 0. Which means that, remember, if the dot product is 0, then the line and the plane are parallel. So it's one of these two, and either there's no point of intersection or there's an infinite number of points of intersection because the line lies in the plane, and over here the line is actually above or below in this orientation of the plane. In other words, the line and the plane are distinct. So those are our two options. So therefore, and we should probably write that, therefore, the line and plane are parallel. Therefore, either no points of intersection or an infinite number of points of intersection. Okay, those are your two options. So, if we're going to figure out which is which, there's two ways to do this. The first way is to basically blindly follow what we were doing in example 1, and we're going to take the parametrics of the line and we're going to plug them into the scalar equation of the plane. So what we're going to do is we're going to assume point of intersection exists, and at the point of intersection, just like we did before, x equals x, y equals y, z equals z. So I'm going to take my scalar equation, which is x plus 4y plus 2z minus 4 equals 0, and I'm going to plug in all the possible values of x on the line in terms of t. So this will become 2t plus 4, 1 minus t, plus 2 minus 4 plus t equals 0. So it's 2t plus 4 minus 4t minus 8 plus 2t equals 0. 2t plus 2t minus 4t, 0t. 4 minus 8 is going to be, let's see if I did that right. That looks good. That looks good. So that's going to be -4. And so it's going to be 0t equals 4. And so let's look at that. Now that's going to bother you. 0t equals 4. The question is really, what value of t will solve this? And the answer is none. There's no value of t that I can put in. Times 0 will give 4. So no value of t will satisfy this equation. Remember, that's the short form for equation. No values of t will satisfy this equation. Therefore, no points of intersection exist. In which case, the line and the plane are parallel and distinct. Now remember, this t value is the value for which we would get any point on the line. Well, it has to satisfy this equation if that point's also going to be on the plane. This is the equation. Any value of t that'll satisfy this will work. No value of t will satisfy this. Therefore, there's no point of intersection. And therefore, line and plane are parallel and distinct. Now, that's great, and that works really, really well. Here's another way. Instead of going after a value of t that will show if there's a point of intersection, what if we just took the point that's on the line and saw and decided whether or not that lied on the plane? So in other words, we've got this or this. We know that we're giving a point on the line. Why not take that point and plug it into the scalar equation of the plane, and if it works, then guess what? There's a point of intersection. If there's one point of intersection, there's an infinite number of points of intersection. So we could check so the point given on the line was 0, 1, negative 4 satisfies and the scalar equation is x plus 4y plus 2z minus 4. Let's plug that in. 0 plus 4 times 1 plus 2 times negative 4. So we're going to get 4 minus 8. 4 minus 8 minus 4 equals 0. And that is certainly not true. That's going to be negative 8 equals 0. And what that means is, therefore, this point does not lie on the line. So the point given on the line does not lie in the plane. Therefore, if we have to decide whether or not the line lies in the plane or whether or not the line and the plane are distinct, this tells me that that point isn't in the plane. Therefore, the line and the plane are in fact distinct. Okay, so that was two ways of doing it. We'll come back with the last one.